So I want to talk to you about what PickNik is doing, MoveIt, and also the title I changed a little bit. I said Space MoveIt. I'm talking about Space ROS. They're very similar things. So a little background on PickNik for those who don't know. We've been around since 2015, and our focus has been supporting the ROS community. So similar to what Open Robotics was doing before the acquisition, a lot of companies have brought us on to help them with using ROS and particularly MoveIt. So we specialize in motion planning with robot arms and grasping manipulation. Got a lot of smart folks on the team. We've worked with a lot of companies, and we're in Colorado. A lot of companies. Here's some of the logos we've worked with. I think some of the folks here might recognize their logo. So yeah, we're one of the top groups in the world for doing manipulation, and we typically base that on MoveIt. And MoveIt is one of the big apps within the ROS ecosystem. A lot of people think of ROS, they think of RViz, they think of Gazebo. They might also think of MoveIt as the thing that you use to control robot arms. And I recommend you check it out. It's open source, of course. This is our website. We have a hackathon coming up. You can see a little announcement here, June 8th. This year's hackathon focuses actually on machine learning. We just released the Python interface for ROS-II. It was a little bit behind because we mostly focus on the C++ version, but the community spoke. And we, at PickNik and with some interns, put a lot of work into getting the Python from ROS-I also in ROS-II. So lots of updates on Python, this iron release. So we're very proud of that. MoveIt's been evolving for 10 years now. We're always adding new features. Most recently, we've done a lot of work on parallel planning, where you can have a bunch of different algorithms for motion planning kind of compete on different cores of your CPU and come up with the best solution and apply that. So that's helping with getting more deterministic motions. Constraint planning has been recently, over the past year, a lot of work's gone to that so that we can specify more tight requirements for how the path is going to look in free space, as well as constrained against the surface. There's always more stuff going in. So yeah, I encourage you to check that out. I don't know if our iron is officially released yet. I think we're working on the release notes. It does exist because we're on ROS rolling, so it comes for free. ROS rolling being the continuous update for ROS-II. So a few more details about what MoveIt is. It's got a bunch of different algorithms in these different categories in these boxes. So there's global motion planners, and this is basically a lot of research from different universities over the years we've collected, as well as local planners, Cartesian, inverse kinematics, using machine learning to come up with different grasp poses. We've different libraries for collision checking. So we support both the fast collision checking library and Bullet, as well as some perception support, although MoveIt doesn't really try to be a perception computer vision library. A lot of companies roll their own and they attach it to MoveIt, and that's a very normal scenario that we fully support. But we do have some basic examples of how to use depth clouds and computer vision with MoveIt. And a lot of this has come from all over the world. So like middle box, Pills Motion, there's a company in Germany called Pills that contributed a set of motion planners that look a lot like traditional industrial automation planners. So L&L and C, and just like direct arcs and interpolations. So we have all of that. Intel's contributed some, just all over the country and the world. It's been really great community. And so again, we partner with companies to build these solutions. We'd love to partner with you guys if you're interested. I got that out of the way. So moving on, what are we up to next? Oh, actually, no, this is an extra file I added. These are some fun graphics of stuff that we've used ROS, particularly ROS-II on. A lot of people still think that ROS-II isn't being deployed. It's not ready yet for production environments. PickNik's been deploying ROS-II for many years now, and it just gets more and more mature. So we're using it for walking cars, for it's operational in oil rigs underwater, ROVs. ROS-I's been used in space. I'll get to that later. We're using it for surgical applications. It's a fork. There's a special version for FDA certification, but it is being used there as well. Like all over the place. We have it in production, picking strawberries in California. I think the growth season is starting, but they're not picking yet. But these are all projects that we've been working on for years. So I encourage you to change your mindset and check out ROS-II. It does work. PickNik wants to do more. So I want to share with kind of like what we're working on now in terms of our business models evolving a little bit. Everyone's changing. Open Robotics acquired by Intrinsic. We are also developing a new software that is going to let anyone more easily set up manipulation and create applications and apply MoveIt in more areas. So this is one of our big initiatives. maybe reducing the amount of senior software engineers, the number of hundreds of thousands or even millions of dollars of R&D you might have to invest to build a system. How do we make that simpler and faster to deploy? And so we call that MoveIt Studio. It's a different project. It still uses MoveIt, uses ROS-I, but it's more of an integrated environment where you might see in this GIF here, it's behavior tree based, which is really hot right now. Davide is a ROS, one of the ROS famous people for his behavior tree work and plot juggler. He's actually at PickNik, so he's helped us a lot in bringing in that to MoveIt. So we have a fully integrated MoveIt behavior tree system. Here's a closer screenshot of what that looks like. And now we can just drag in these blocks and put together some pretty advanced manipulation applications. And you can use your own blocks, like you don't have to use ours, like it's totally extensible. This is all standards. The behavior tree.cpp project is available. And so here's an example of a prototype we threw together in a couple days using MoveIt Studio and behavior tree. So we didn't have to write any custom code for this, but we were able to create a bin picking solution for a customer we're working with very, very quickly. And there's still a lot of work to do in terms of getting this to a deployable state, but I just wanted to show this as an example of the power to quickly prototype using this approach. See if I can approve the next video so I can share it. I'm on my phone because I'm approving the video. It's not coming through. And what, I'm not sure. Okay, so what we see in the bottom right here is this behavior tree is kind of like a state machine. You can actually see it live, showing you what node you're on. If there's a failure or an error, it'll pause. You can drop in and actually debug. It'll give you feedback. So we're trying to make a lot of the feedback we got from the MoveIt community is like, oh, my motion planning fails, and I don't know why. Like we don't have any introspection into what's happening. Was it that there were no valid graphs found? Was there no approach? The approach distance is wrong. We're trying to go outside of our reachability like space. Which part of a multi-step motion plan pipeline failed? And that's what we're working on solving with MoveIt Studio. And there's a lot of cool features around that. Let's see if I can go to the next. Okay, so this is where I can't show. Do I have to press a button? There we go. I just think this is a really cool thing I want to show. This is live editing here. Okay. Bear with me here. Sweet. Oh, okay. Well, I'll just explain it. We just recently, I'm just excited about this, connected the large language models, LLMs, to behavior tree generation. So we can just type in a command, a sentence, and this blows me away that our engineers can do this. It'll automatically populate a behavior tree. And in some cases, it just runs. Sometimes you have to go and like it starts hallucinating, which is great about ChatGPT type stuff. And it creates the wrong behavior tree, but it's still a good starting point. You can go in and just like fix the thing that they got wrong. And so we think that's a really cool new way of making it really intuitive to program robot arms. And it's just, I'm still, my PhD was not in LLMs. So I feel a little old school now, like the graph-based search model that we use with RRTs and PRMs. It's a field of algorithmic development that is still very powerful and MoveIt's great at it, but there's also all this new work. And so we're trying to make sure that we are also developing that. So I'll continue on, but if you want to see the video afterwards, I can definitely show it. Just a little clarity on the difference. So there's kind of two parts of what we're developing. There's a set of developer tools that our team's using to make their life easier. And we think other companies, other engineering teams can use to do things like, debugging your motion plan, like I said, creating waypoints, create your planning scene, whether it's from just scanning 3D meshes or importing CAD files, doing reachability analysis, benchmarking the cycle time, the performance. So a lot of our customers come to us saying, hey, we're picking at 10 seconds a cycle. We need to get down to like 3. We're like, what? That's a big jump. Okay. And so we have all these like professional services we provide where we like will optimize your code to go faster. We're trying to systematize that into a toolbox and making good progress on that. So here's some of the pieces that are provided in the developer tools. We also have a version of SDK that's kind of like a version of MoveIt that's more like production MoveIt, and it's going through a full QA process. We've had to narrow down the API. So there's less surface area that we're supporting, because right now people use MoveIt at any layer of the stack and it creates this crazy attack surface. So we are going through a much more rigorous QA process. And if you use this SDK, this interface, we will provide warranties, guarantees, support, uptime guarantees. So that's a development. MoveIt's not affected though. You can still use MoveIt open source. You don't have to use this. Just one of the things we're working on for some of our customers who've said to us, hey, we need this to be more reliable. We can't rely on this otherwise. And our team is there to back you if you choose to use this. And just want to clarify, this MoveIt Studio thing, it's very extensible, so you can build on top of it. A lot of our customers, they're working on the ML piece themselves. They're building these models, and they just want it to be able to connect to a high functioning motion planning kinematic system, and we provide the SDK for that. So it's all based on ROS-I. We have Python interfaces, C+ interfaces, and the documentation is live. So docs.picknik.ai, you can check it out now. So changing topics entirely, I want to talk about space. And PickNik's kind of crazy. We're doing a lot of different things. We've worked in really every industry. The pictures earlier, you saw the diversity. But now we're working on some space stuff. I'm not sure how much you're following it, but the commercial space industry is blowing up. And there are a lot of parallels with industrial. I know this is an industrial event, like where to automate, but some of the business plans that they have is manufacturing things in space, where there's some nice properties. When you have low gravity, you can get better production yields. There's still a lot of issues around how do you return the materials down to Earth in a cost-effective way. But I'm not an expert on this, but it seems like the economists and the business analysts think that there are actually, with the lowering cost of lift, with SpaceX's progress on the Starship and so forth, that actually manufacturing in space is a viable thing. And there's a bunch of new commercial space stations going up in the next decade. 3 is the current plan. Plus, there's the Chinese one already up. So the Sierra Space, Northrop Grumman. I forget the other one right now, but there's a couple. So there's a lot of need for robotics in space, and so companies are coming to us asking for okay, how do we do this? And so we're trying to transition some of the learnings from the industrial sector here on Earth to space. Of course, there are special requirements, but we want to bring ROS to space. And so you've probably heard on ROS discourse or some rumblings of space ROS. And I just want to give dispel some myths and some questions. I'm happy to answer other questions at the end. I don't have a lot of time here, but ROS has already been to space, and MoveIt's already been to space. Both these pictures are ROS-I. For ROS-II technically has not, but we're trying to get a mission later this year to run a ROS-II based system with MoveIt Studio, I just showed you. And we also, there's some groups at NASA that have 2 launches that they haven't officially announced, but the word on the street is that we'll be running space ROS as well, which is really exciting, because in the space industry, having flight heritage is king. If you don't have flight heritage, they ignore you. They're like, this is a toy. But once you have that, even if it's just a little experiment on the ISS, it makes a big difference in perception. So the Space ROS group are working hard to start changing that perception by having some flights. But again, ROS has run in space. These are 2 experimental missions, so they're not Class A. They didn't require human safety ratings. They weren't supporting the life support of our astronauts. They were toned down to the point where the velocity and the force was limited, so it was a safe environment. But actually, the Astro Bee is currently there. The Robonaut program on the left, that's over, but the Astro Bee is actively being used, and they are also upgrading to ROS-II currently. The group at NASA Ames up in Mountain View. So how did we get involved with it? Just some backstory. We just got a bunch of SBIRs and STTRs with 2 different NASA centers, as well as most recently Space Force. We're on a phase 3 SBIR with NASA Johnson Space Center. So they're using MoveIt Studio every day on their research and ground operations. And we're hoping that will then translate to a space mission. Particularly, we're currently funded under a lunar program where there's the Artemis program. And the plan is to have humans living semi-permanently on the moon in the next decade or half decade, depending on whose timetable you believe. And robots will go first, and they will do some of the initial setup is the hope, and some of the construction. Particularly, there'll be a lot of autonomous resupply capsules landing, and we need to get the resupply materials off and put away into the lunar the life habitat, because astronauts actually won't be on there all year round. It'll be a couple months a year is the initial plan. And so the other parts of the year, we need robots to maintain those systems. And so PickNik's hoping that we can bring ROS and MoveIt and some of our tools up there to help with that. And NASA's really excited about that. So they're funding this. Here's another photo of the Astrid B. I think I already talked about this, but we want to get our testing on this little cube. This doesn't have an arm, and we typically work with arms, but there is a cool little perch arm, like a little bird leg that can like land on things and just kind of rest. And we'll be testing with that as well. So in order to put MoveIt in space, we need to have ROS in space. And so there's this existing effort the past couple of years to have space ROS. And a lot of prior work, let me skip to this slide. A lot of prior work has been done by Open Robotics. So Kat could probably speak just as well as I could at this point about what space ROS is. It was really kicked off by Blue Origin, so a big name in the industry. Rumor is it that Jeff Bezos didn't like it when he heard about it. And so Blue is kind of backed out of it, but there's still ongoing efforts. NASA's put some funding into this. And PickNik, we're applying to a lot of other programs of record and with NASA to continue the development. So there's a little bit of a lull right now. There's still work happening, but not as fast as it was happening with Blue Origin. And we're working hard to make that resume. So let me go back to this slide. There's some flight requirements or it's flight standards. So this DO-178C and some other ones. Every industry has their own requirements. Like we've done some of these surgical systems for medical applications. They have their own set of standards. Automotive, like the Autowear Foundation, has similar standards, but actually they're all pretty similar. It's all about real-time memory allocation and validation of like different static analysis tools, and like they're just like different but similar. And so we think that all these communities can work together on ROS2. And already, I mean, that was one of the big design criteria of ROS2 was to enable it to be more real time. And a lot of great work was done there. And we're going to continue that work to get it to have the verification and the documentation needed to convince NASA and other space groups. And they're a little bit hesitant because there's a lot of legacy work and they've had some pretty big disasters in the past. So we have to overcome that. So we're working through that process of having the right requirements gathered and having tests to prove that we can meet those requirements, even eventually getting to a Class A mission where humans can depend on these systems for life support. That's probably further away though. And we believe that the benefits to the space industry are huge because the state of the art right now is every mission is bespoke. It's this unique butterfly. And then once the mission's done, most of that software, if not all of it, gets thrown away. And there's a lull where there's a couple of years of no funding for something. And then companies like Lockheed get the next big contract and they kind of restart. And that's just, we know from this group, it's not very sustainable. So we're trying to make it so that we can lower the cost of robotics missions and reuse a lot more modular components. NASA loves the term modular, and they use ROS heavily actually. And so they're very in support of this. We've been to a bunch of NASA centers the past 2 years, and every one of them have research groups using ROS every day. They just don't launch it. When it comes to launch, they are doing the old school approach. We're working with them to make it so that it can see it through the whole launch cycle. And again, ROS is great, as you know, for the community backing of it, all the students learning it in school, the fact that different centers and different companies can work together on the same communication layer, having these standards. So I'm excited to be a part of this. With the recent change in OSRF structure, I was actually appointed the chair. So I'm the organizer of the meetings, but really leading on the whole space industry and community, folks like Aswiri as well, to help with this effort. So it's a big community effort. Another thing is like people think, oh, space ROS is coming, it's in the future, but I wanted to dispel that myth because it already exists. Kat's done a great job of launching the space.ros.org website. Encourage you to check it out. Open Robotics got the space ROS GitHub repo up before the switch over to Intrinsic as well. And if you go look at that GitHub, you won't see much. There's some special CI builds. There's some tooling that helps verify the code, but all the real work has gone into upstream ROS2, which means we all benefit from the work of space ROS. And the hope is that we can not fork for as long as possible, hopefully never. And so the great work that was already done has improved ROS2 for all of us. It's in Iron, the changes. It's in Humble, I believe, too. So that, yeah, the prior work's been static analysis. There's been some testing. There's like a dashboard that tells you the health. And there was work to set up a special distro where you might have the ROS2 Humble, ROS2 Iron, but you have a special space ROS distro that has to go through an extra verification step, and that's just kind of what you have to do in the industry. But there are upcoming meetings. I'm not talking to a space group, so I don't know if this is worth mentioning, but there's a monthly developer group that's just launched, and there's also about quarterly community meeting. We had one in January last, and another one's coming up soon. I didn't get the dates in here, but I think I have them in my inbox. I just got to work through that. And that's about it. A quick summary. MoveIt is very applicable to your industrial applications. So it's been used in a lot of factories. It's been used in a lot of robots outside of factories as well. It's like actually a sweet spot for PickNik. We love working on the more unstructured problems. So the things that you can't get solved by all the amazing booths here at Automate. If you're working on something that's harder than what you see on the floor and you're like, okay, I have an R&D team, how do I solve that? Use MoveIt, use ROS Industrial. Love to talk to you. And MoveIt Studio is a developer tool that can be used for terrestrial applications. We're also working on using it for space. And finally, Space ROS, it's just ROS2 with some extra code quality guarantees. And we're trying to keep it an open community there. And there's some links at the bottom for more information. And with that, thank you.
Wow. All right. So we're doing good on time. Other questions for Dave? Yes, Dr. Webb.
Yes, great talk. So a question about the space. So space, many positions there are some unique attributes which are not typical for terrestrial industrial robots. We have tremendous point flexibility. I have also cohesion motion for 70-degree response rather than choose more organization, freedom, and that will tax the environment again. So, how do you envision development path for the space versus
Question was, what's going to be the development path of MoveIt Space? Because there's some unique requirements. I'm not quite. I followed about the extra null space, and that's true space and Earth, right?
Right now, the space menus that there are 70 degrees, right? The 70 degrees, of course, you can use null space, but the current way to get a surface of motion, but we're on right into their algorithm, like that, that certain implication of similar structure and motion. There are different parameterization of that, redundancy,
Yeah. I'm not sure I have a great answer for that. I know the state of the art right now for a lot of space arm control, like MDA in Canada, they have the Canada arm. It's a lot of more like mindset of like teleop, where you're pre-scripting some waypoints on Earth and you upload it. That's been a big progress. It used to be that an astronaut was looking through a window on the shuttle and just driving with a joystick, but now they're actually scripting it. And I think to avoid to solve for the redundant joint, the extra, I think it's kind of a manual step still. I'm not exactly sure. Yeah, so what NASA's excited about working with us is the more automated approach where the buzzword supervised autonomy. And so we've done a lot of work on, there's a human in the loop, but they're giving it very high level commands. So we have a lot of click to grab something or click to pick. And then the algorithms in MoveIt, they just automatically will come up with a plan. We have constraints, so we can kind of specify a cost function and try to reduce the elbow swinging in the wrong direction. And then they really insist on having a preview plan. And so you can see in simulation what's about to happen, and you can have the various committees of NASA all scratch their chins and say, okay, it looks good. And they approve it. It goes back to space and the robot executes. When we talk to the teams who have been operators of the rover missions on the Mars, it's really primitive approach. They're just writing scripts on a command line and sending it up, and they just their tooling is still pretty behind. And there's reasons for that. Getting software certified for space applications has been historically very hard, and they also are very limited on their compute. So that's a thing that's working in our favor, I think, is in the past few years or decade, there's been a change where space applications aren't just using FPGAs anymore, which is what the old paradigm was, but there's actually a lot of ARM core architectures and full kernels. And RISC is the new standard, I think, that NASA's getting behind, where we have more powerful CPUs and even GPUs to use. And so that's why it's like the right time for ROS to go to space, is that there's more embedding. So we can do a lot of fancy stuff with our algorithms and constraints. I'm not sure if that answered, but.
Thanks, Dr. Knight. Yes.
The MoveIt Studio behavior tree interface. So only for movies related packages or nodes, or can it be used with any other node as well to basically automate or structure the whole package?
Yeah, we've been debating if we should even call it MoveIt Studio. We've done a great integration to make it work with MoveIt, but you can certainly make your own behavior nodes that work with anything. It could be Tesseract nodes. It could be Nav2 or just controllers for a PyTorch ML model that you want to trigger. It is fairly agnostic, but we did put some extra flair into the application to make it work really well with robot arms. So we are focused on some of the manipulation cases. You could ignore that part, but good question.
Kosh.
More question. So Tesseract, like Diverge, is there any sort of plan to bring them together again?
So it's funny you mentioned that. We actually had some conversations about this week, right? So obviously there's lots of good work going on in both. We're trying to identify areas where there's really great synergy. So obviously if there's enhancements to trad jobs, low-hanging fruit, on the space ROS, we're interested in the fires, but absolutely, right? We can see a difference, right? We are excited about that.
And we did initial work to take some of their trad job work and see if we can get it back into MoveIt, which was on my slide earlier, because the trad job work has been fantastic. You guys have done.
Likewise, we're pretty excited about the behavior tree work and we've been doing. Yes.
Talking about the behavior tree visualization, I guess what's kind of the overlap of the Venn diagram of MoveIt Studio and like Group 2.0 and interacting with the behavior trees, the library?
Yeah. So Davide is working with us, but he's also working on Groot. That's a good point. Groot is a much more atomic small tool for just visualizing behavior trees, which has got advantages for sure. It's a desktop Qt app. Our stuff we can run in the cloud from anywhere. It's a web app, and we've integrated it to where you can drag in these blocks and then click run, and immediately it'll trigger the robot. And if there's an error, it'll drop it and show you in a visualization where the error was. Trying to make the messages much better than what you saw in MoveIt. There's still work to be done there, but whereas Groot is kind of just the behavior tree bit. So there's pros and cons of the two approaches.
Yes, this might be about our last one.
Awesome. What sort of custom secret sauce are you actually putting in the unique notes for MoveIt Studio to make it so that it interacts with the behavior tree with the minimal development?
So there's like a button where you can like create a new behavior. We call them behaviors, but they're like leaf nodes, same nomenclature. And it'll create a code template in your Coleman workspace that you can then fill out whatever you want. But it automatically has the hooks for ROS2 and for the MoveIt library. So you can hook into anything the MoveIt stuff. And yeah, there's been a lot of synchronization, like extra sauce we've had to do so that we can track the state of all these things and abort when we need to. If there's an error, it will actually zoom into it and like kind of highlight it red. And it's like the integration. I'm not on the engineering team anymore, so I can't say exactly how they did it, but I'm sure you could ask one of them if they were here.
Thank you.